So we're going to go over a substitution today, and it's really similar to order of operations. It just means that we need to take a number, plug it into the expression first, and then follow order of operations. So it's going to be an expression like this, where we have a bunch of variables, and then they give us numbers. They say that x is this, y is this, and z is this, and then basically just plug them in. And then follow order of operations. The important thing is that we're going to plug in all of these numbers in parentheses. And that might seem weird. It might seem like we're adding a grouping symbol, but we're really not. We're just saying that the whole quantity, whatever it is, like in this first example, x equals -2. The whole -2 is squared. We're going to put that in parentheses, actually. Let's show that. First, I'm just going to open up parentheses so that I can drop those numbers in there. I'm just going to put parentheses in place of each of these variables, and then I'm going to substitute my 3 numbers in there. So -2 squared minus 6 times 2.2 plus 3 times -7. It's important for a couple reasons, especially important here. This is different from -2 squared without parentheses. This will give us a +4, while without parentheses it would give us a -4. It's also going to be important on the last part of that expression, 3 times -7. You want to make sure you don't write that as 3 minus 7. It's 3 times z in the original expression. It should be 3 times z, or 3 times -7, in the final expression. Make sure you put the parentheses there and then just substitute the numbers in. You need to do this every single time to protect you against making silly mistakes. On the second one, I'm going to do the exact same thing, set it up with just parentheses in place of all of our variables. We have a, b, and c, so I have 3 sets of parentheses here. Then I'm going to plug in my -2, 10, and +2. And this practice section is just looking for you to plug those numbers in. You don't need to solve anything. I just want to show you that it's really important to set these expressions up with parentheses here. Alright, 3 little distinctions just to make sure that we understand the difference between all of these examples, because they are very different even though they look very similar. So the first one, we have a negative in front of the x, or a minus sign in front of the x. Those are really the same thing. A minus sign and a negative sign are actually the same thing. Here we're saying it's a negative, or the opposite of x. So the opposite of whatever number we're going to plug in there, and here we have an x that's a negative number, so the opposite, or -5. That changes into a +5. You can see there's 2 different ways. You can see this as a -1 on the outside of the parentheses that's being multiplied into here, or you can see it as subtracting a negative number. Subtracting a bad thing is actually adding a good thing, so we have a positive number. It's the same thing as adding a +5. The next one, same thing. I'm going to set it up just with parentheses. Something squared, it's really -5 squared, which is -5 times -5. The entire thing is being multiplied by itself, and we get a +25 from that. Negative times negative gives us a positive. Third one's basically those 2 things put together. We have a negative on the outside of the something squared, just plugging in that -5. This one has a negative on the outside, so the negative is not affected by the squared. The negative sits on the outside. Before you change this minus sign, this minus a negative, you need to square this. Really, you're doing subtraction. You could also see it as multiplication, but either way, it's happening after this exponent. So we have to do the -5 squared first. -5 times -5. We multiply those 2 together. That gives us that +25, and then we apply this minus sign and change it to a -25. So we get down to our first problem here. It's the exact same thing as order of operations after we plug these numbers in. Make sure you do it in parentheses, and then you could just follow PEMDAS to take it step by step. Alright, so on the first one, I'm going to start just by setting it up with parentheses. All I'm doing is putting parentheses in place of all of these letters. And then I'll take my x, y, and z and plug them in there. So really I haven't done anything. I've just substituted x, y, and z. Now I'm going to follow order of operations. I'm looking at this. I have no grouping symbols really. I mean, I have the grouping symbols. I have parentheses, but I can't do anything inside of there. So I'm going to start with my exponent here. That's -5 times -5 times -5, or -125. I'm not changing anything else. Then from there, I have really a subtraction sign here. I have division, addition, addition, and addition. I'm going to start with that division. That would give me a -2. I'm going to keep that in parentheses for now, just to make it clear that these are 2 different operations, adding a negative. I like seeing this in parentheses just to separate these 2 operations. On this next step, I'm going to actually drop all of those parentheses. I'm going to apply this negative to this 5, just changes it to a -5. I'm going to apply this plus to this negative sign. Adding a negative is the exact same thing as subtracting a positive. So adding -2 is the exact same thing as this, which is subtracting a +2. Adding 4.5 doesn't change, and again, same logic there. That's -125 now. Now we just go straight across. and that's negative 127.5. Second one, set it up the exact same way. Just put parentheses in place of all the letters, and then take your numbers, your values, negative 16, negative 4.5, and 1/4, and put them in place of those letters. One thing I did here, I changed that 1/4 into a decimal. 1/4 is really a division problem, and I'm about to plug it inside parentheses, so I know I'm about to start with that grouping symbol. That would actually be my very first operation. Instead of doing that, I'm going to plug this in as a decimal, which I know is equal to it, so I'm going to plug it in as 0.25 instead of 1/4. Now I'm going to follow order of operations. I'm going to work inside this grouping symbol first. Negative 16 is really just a positive 16, so that's really all I'm going to do on the first step. I'm going to keep working inside that grouping symbol. The square root of 16 is 4. So that's really all I've changed so far. I just changed that to a positive, took the square root of 4. Now I'm going to do this multiplication at the end of the problem. 4 times 0.25, that would give us 1. And now we'll go left to right. Subtracting a negative is really the same thing as adding, so it's 4 plus 4.5 plus 1. And now you add those up, that's 9.5. You could plug this into the calculator if you don't feel comfortable changing it to a plus. Subtracting a negative 4.5 in the calculator works just the same as adding a positive. Alright, on the third one, I'm not going to put the parentheses there as my first step anymore. I'm just going to plug the numbers directly in parentheses. So all I did was plug in the negative 3 and this negative 1/2, which is really the exact same thing as negative 0.5. I just did that division, 1 divided by 2. Make sure you don't do 2 divided by 1. Always do the top number first. And now we'll follow order of operations. Remember, a big fraction like this, we can solve the top and the bottom at the same time, so that's what I'm going to do. I'm going to start inside the parentheses here. That's my grouping symbol on top, and I'm going to do the exponent inside of there first. I'm going to follow PEMDAS inside the parentheses. So I'm going to square that 9, I'm going to square the 3 and get 9. And I'm going to change this symbol, minus and negative, into a plus sign. Again, you don't really have to do that. You can plug this into the calculator. Negative 4 minus a negative 3. It's the exact same thing. It'll give you the exact same result as this will. Now I'll do the last step inside the parentheses, just that subtraction. 9 minus 7.8. That's 1.2 there. And I'll do the addition on the bottom. Negative 4 plus 3. Now I'll multiply from left to right. We really don't have anything to do on the bottom or with this plus 6 over here. We're just sticking with the top. We're going to figure out what that number is first. Really just going to multiply left to right, which is what gave me this negative 1. And then we're going to continue with that. That gives me that negative 2. Nothing else has changed. Multiply one more time. That gives us negative 2.4 on top. Now we can actually divide these. That's completely simplified. That's completely simplified. We'll divide those two. You get a positive 2.4. And now we can use this plus 6. We have to simplify everything in that big fraction and then just add in this 6. That's 8.4. Alright, on our fourth example, same thing. We're just plugging those numbers in place of each of those variables. A goes in place of A, B in place of B, C in place of C. And following order of operations, we see that we have this big grouping symbol. We're going to work inside of there first and follow PEMDAS inside of there. So there's no extra grouping symbols inside of there. But we have an exponent, we have division, addition, this is multiplication, and that's subtraction. So we're going to do this exponent first. That's negative 4 times negative 4. Or 16. And now we have division, addition, multiplication, and subtraction. We have division and multiplication here. We're going to work that left to right. Anytime we have just those two left, you go left to right, so we'll do the division next. And that gives us 4. That's 16 divided by 4. Now we'll do the multiplication. 8 times 4.5 would give us that 36 that I'm showing there. So now inside the parentheses we have an addition and a subtraction. We can just work that from left to right. That's 40 minus a negative 5, or 40 plus 5. We can add those inside the parentheses. That would give us 45. And now we have a division problem in the beginning. That's being multiplied times something which has an exponent. So we have to do that exponent first. That's 2025. Really, I'm going to do this next part in one step. 1 divided by 4 would give you 0.25, and then we're going to multiply it times 2025, and that's 506.25. Alright, the word problem's on the back. We're going to start off with the formula used to find the area of a triangle as 1/2 base times height when B stands for the base and H stands for the height. Find the area of a triangle that has a height of 4.5 and a base of 3.8. Make sure you see they flip those around. The B comes first and then the H. So our formula with parentheses, we're going to plug that 3.8 in for the base and 4.5 in for the height. I'm going to change the fraction into a decimal, change that into 0.5 just by doing that division, 1 divided by 2. Really now I'm just going to multiply straight across. 0.5 times 3.8, that number, which is 1.9, times 4.5. And that gives you 8.55. The units here are going to be inches squared. We're talking about the area of a shape. So that's square units that it takes to cover a shape. That's why I'm using that. We're going to talk more about that during the measurement unit. Second one's a little bit trickier. Now we want to find the missing side of a right triangle, and we're using this formula: a squared plus b squared equals c squared. You might have heard about this last year. It's called Pythagorean theorem. It's going to be important later. If for a right triangle, a equals 3 and b equals 8, what's the value of c? Okay, so we're going to start this the exact same way that we started before. Plug those numbers in. So we have 3 squared plus 8 squared. I'm actually going to do both of those at the same time. I know I'm going to end up squaring both of these numbers. So 3 squared is 9, 8 squared is 64. Now I'm going to add them. That gives us 73 equals c squared. That's not our final answer, though. This is saying what's the value of c. So we want to get just c by itself. This is saying there's some number times itself, some number squared, that gives us 73. So working backwards, we're going to actually do the opposite operation. We're going to learn more about this in a little bit. Solving an equation uses the opposite operation. So the opposite of squaring something is the square root, this check mark kind of symbol. We take the square root of both sides, because anytime you're solving an equation, you have to do that on both sides, and that gives us 8.54 for that side. So c by itself equals 8.54. Number 7 uses the interest formula. That's I equals PRT, where P stands for the principal. It's not really clear there what principal means. Principal is the amount that you start off with. Like if you're taking out a loan of $20,000, $20,000 is the principal amount. If you start a bank account with $5,000, the starting amount, that's the principal amount. R stands for the rate. We have to change that into a decimal. We'll talk about that in a second. T stands for the time, and that's always in years. Here, that's not going to be a problem. We are given years, so we're just going to use that 7. But later, if they give us months or anything else, we need to change that into years. So it says if Mr. Nickus invested a principal amount, an original amount of $1,300 in my bank account at a 1.5% interest rate for 7 years, how much interest will he make? Well, first off, I'm going to invest my money better than that. I'm going to do better than 1.5% per year. But let's just use the example. I equals PRT. What this is really saying is that we're multiplying all three of these. P times R times T. So I'm going to substitute those numbers in. I put this as a percent for now, but I can't operate with a percent here. I'm not allowed to use decimals times a percent here and then times another decimal. I have to change everything into the same form. So I'm going to change that into a decimal, which is 0.015. You can take this and divide by 100 to get that, or you can move the decimal place 2 places. Either way, it's that decimal. And when we multiply those three together, that gives us this $136.50. That's how much interest I made over 7 years. So I'd have a total amount of $1,436.50. That's if I needed to add it to this. This is just asking how much interest, so this is our final answer. If they're asking for the total, you would add it in. All right, finally, number 4. The formula for finding volume for a cylinder is not there, but it's down here. V equals pi times r squared times h. What's the volume of the cylinder below? So we have the entire way across here, that's 11.7 millimeters, and the height here is 19.2 millimeters. Now that's not exactly what we want to use. So we can see in the formula, we really need the radius, but this whole way across is known as the diameter. We want halfway across. We don't want to use the full thing. We're going to divide that by 2 or multiply by 1/2. Those are the same thing. The radius is 1/2 of the diameter. So that tells us that the radius is 5.85. So now we can plug in that 5.85 as the radius. I changed the pi into 3.14. In general on the SOL, I think they use 3.14 instead of the pi key on your calculator. If you ever use the pi key on your calculator, I will never mark it wrong. But just know on the SOL, that's the number that they're expecting you to use for pi. So 3.14 times 5.85 squared times 19.2. We're going to do that squaring first. 5.85 squared, that should give you about 34.22. And then you multiply it times the other two numbers times 3.14 and times 19.2. And that gives you this big number for the volume. Now these units are cubed because we're talking about the space it takes to fill an object. Those are cubic units, or cubic millimeters in this case. Good luck on the practice on your own. Please ask for help if you need it. Math away.